So, section 3.2. Now, we're going to talk about protocols. We're going to talk about adhering to these protocols. There was and forgive me if you're actually in the class, because I forgot who did it. Somebody, as you read through the posts and replies, was asking questions about the OSI and the TCP/IP model. Okay? Those are two different standards. Same standards, different concepts. We're going to talk a little bit about that today. So, protocol suites. What's the protocol for human communication? We have to have an idea. We talked about that. We have to have rules. We have some. Again, language, who's going to talk, and when are you done talking? Pretty straightforward. And then you have the physical layer. What would be the physical layer? Looking for one word here. What would be the physical layer right here? What word am I looking for? These two are going to communicate. What form are they going to communicate on?
Would that be the
What's that?
LLC?
Okay, verbal is one version of what? The medium, right? So what if it's a letter? They're writing it down and passing it. They could do that, right? Okay, keep that in mind. So the idea behind a protocol is, and if you ever see this in a question, always go for this answer. If they ask you what is a protocol and you see the word rules in the answer, take it. What are protocols? Rules. Rules. Okay?
Standards.
They are standards. But stick with rules. Just very simple. Protocols are rules. Everybody has to have rules. Okay? Now, let's talk a little bit about our world and networking. We talked about, this is going to go a little high, so work with me here. We've talked about these layers. I keep accidentally mentioning these layers. These layers represent a concept. There is not a layer 3. You're not going to reach out and touch a layer 2. These are concepts to help understand technology. Now, what do they mean? So, this is a computer over here. He's sharing some information with a web server. And what do web servers do? Just in general, what do web servers do?
Store.
They don't store. Well, they do store, but what's their main purpose?
Distribute.
Distribute what? Information from what? Websites, right? HTTP, whatever. They all get stored on web servers. Okay? What has to happen for that? Well, if you want to talk to Google.com on your computer, say you want to check your email, for example. Well, let's go to CNN.com or something, I don't know. You want to go to CNN.com and you're sitting at your computer screen. What do you have to do first?
Type it in.
Type it in what? Web browser, right? What is a web browser? Application, right? Are you going to go to a chat utility? Are you going to open up your word processor to go to a website? No, you open up your web browser. So at what point is a web browser part of our world? It's part of the application layer in this particular model. Now, the application is using what protocol? Ooh, HTTP. What's HTTP? Hypertext Transport Protocol, right? Has anybody ever heard of HTML?
Yeah.
What is HTML? It's not the address. It's what? Hypertext Markup Language. What does HTML do for you? It's the code that wrote the page, right? The pictures, the texting, the website you see was written in HTML. Again, what does it stand for? Hypertext what? Markup language. Okay, again, what does it stand for? Hypertext. Stop there. If we have hypertext, how do we move it along the line? With a transfer protocol. Transportation, right? So we have hypertext. How are we going to get it down the line?
FTP.
HTTP, right? Hypertext Transport Protocol. So you type in http://google.com. What comes into your computer? A web page, right? What's really coming into your computer? HTML. Okay? So, application layer is good. Now, that got the code there. What got the code to your computer? Some kind of transportation on the network level, right? So we have the transmission control protocol. I always get a kick out of this. I just like a kick. It's really kind of a sick joke. I asked you earlier what protocol do we use mainly, and what did you say? TCP/IP. And I told you short form of that would be IP. Okay. Be patient with me here because it's going to come up again. Why is it called TCP/IP? Well, this is rhetorical. I'm just going for it.
IP is for Internet Protocol, right?
IP stands for Internet Protocol. It does. Okay. There are two parts to that protocol. Just two. It's very simple. There are two parts to IP. TCP and UDP. That's it. TCP and UDP. We'll talk about those in more detail when we get there, but that's not a big deal. So why is it called TCP/IP and not TCP/UDP/IP? Why is it called UDP/IP? Don't answer. It's rhetorical. I don't know. But don't get confused when you see TCP/IP. TCP is part of IP. And there are only two parts. And we'll talk about those. They're not that complicated, but we'll talk about them. So that got it there, okay? And we'll talk about the purpose of this protocol later, because this fits in nicely in our conversation. Then we have the IP, the Internet Protocol. The Internet Protocol is the protocol that has your address. Your address, yeah, your IP address. You ever heard of that form, that concept, your IP address? There are only two parts to an IP address. Two parts. What are the two parts? We talked about them a little bit ago. I'm going to send you guys, I'm going to send you some information out where?
Broadcast.
No, not a broadcast. I could, but more generically. I'm going to send it. No, less generic than that. More generic than that. Do I want it to go to those people? I want it to go to you guys. Where do y'all live? On the network, right? So I'm going to blast this information down the network, but I only want it to go to y'all, so I'm going to send it to your network. Who gets it? Everybody has their own unique IP address, right? So this is kind of synonymous with, if I'm going to send you a letter, I'm going to send it to your street address. That's your network. All y'all live on the same street, right? Presumably. And what about your computer number? Would be synonymous with houses. If I'm going to send information, or I'm driving to your house. I don't really care who's there. I'm going to drive to your house. I know you live in, I don't know, Dallas. Okay, so you give me your street and you give me your address, I'll find it. Anywhere. You give me your street. What if you don't give me your street? You just give me your house number. Can I find you? No. What if I just get the street but no house number? No. All I need is your street and your house number. Same thing with IP addressing. There's only two parts, the host and the network part. The network. Where's it going and who's it going to? That's it. It's not hard. Network access. Ethernet. Everybody know what Ethernet is? You've heard the term? Ethernet are these blue cables hanging out the back of your computers. That's how you're tied to the network. Ethernet is a protocol. Okay? What other form of communication have we talked about briefly? Wireless. Wireless is a protocol. Can you put wireless data on a wired network in the same protocol? And what's protocol mean? Rules. They have different rules, right? You think they can communicate? You think a wireless network card communicate with a wired card? No, they have different rules. So, as an idea for a protocol stack, it's pretty simple. Okay? We want to access the network. Where are we going? How do we get it there? And what information do we want to send? It's Pretty straightforward, nothing complicated there. Okay, pretty simple picture. Now, protocol suites. Okay, well, bear with me. Hang on, we'll take a break in a minute. Okay, a little bit deeper. Okay, what looks familiar about this screen that we just saw on the last screen? Application, transport, internet, network layer, right? Network access. We just saw that. Let's compare some of the stuff we talked about. Network access. We talked about Ethernet. That's the cable. Wireless LANs. We talked about wireless. We also have point-to-point protocol. Anybody ever use point-to-point protocol? Anybody use a modem? Then you use PPP. Yep. This is a dead technology, and this is a way dying technology. We don't care about them. Okay, so let's look at what's the internet layer. What did the internet layer do for us? What protocol was the internet? IP, right? Okay, so where does that live in here? IP. The IP version that we use, that you're used to using, is version 4. Okay? Version 6 is a hideous monster, and we avoid that at all costs still.
Why is it a hideous monster? I thought they were using P6.
IPv6.
I mean, you know.
IPv4, you're used to seeing an IP address of like 192.168.0.1 or whatever, if you tried to program your Linksys router at home. Those 4 octets, they represent 32 bits of address, 8 bits apiece, times 4, okay? We will draw ones and zeros all over this room by the time we're done with that. You will get that, okay? IPv6 is 128 bits. So, significantly bigger. Off the charts more complicated. Way more complicated. You don't even want to go there yet. Okay? So that's the internet layer. What happens at the transport layer? There's your TCP and UDP. Okay? What about application layer? What did we do at the application layer a minute ago? We did 2 of those. What 2 did we do? DNS, domain name, right? Okay, gotta know what google.com means. DHCP, anybody ever use DHCP? Oh, yes, Dynamic Host Configuration Protocol. What does Dynamic Host Configuration Protocol do? Gives out IP addresses automatically. When it first starts up, okay? First off, let's go back for just 1 second. Work with me here. What are network administrators? Lazy. There are 2 ways to do things in networking. Manual and automatic. Which one do we prefer? Automatic. Now, what did I tell you about your network right here? It's your street, right? What do you all have to have uniquely? An IP address. Host address, right? Would you rather me issue your host addresses and you configure them, Or would you rather me give you an IP address for a dynamic host configuration server and then your computer boots up and goes and gets it and comes back automatically? Yeah. Woo, we sure don't do that. Now, how many computers do you think are in the world? A lot. Okay, let's just narrow it down. Which, by the way, I gave you inaccurate information the day about our school district. I was reviewing our conversation with my boss the other day, and he informed me that we don't have 80,000 devices in our network. We have well over 120,000. Every single device has to have an IP address. Not just an IP address, but a unique one. Nobody can have the same address anywhere. Would you want to assign those manually or automatically? Automatically. So the protocol that does that, DHCP. Now, how many of you are using the internet since you've been in this class? A few of you, right? I mean, it's okay. I get it. I don't mind. Did you have to put an IP address in your computer? No. So you've actually used, if you went to the internet, you used HTTP, DNS, and DHCP. What's this nasty one? File transfer protocol. File transfer protocol, which implies what? Rules. DHCP, HTTP. This is also a protocol, but they didn't put the P on it. What is FTP? File transfer protocol. Have you used that today? Don't know, do you? Just maybe you haven't, maybe you have. Have any of you downloaded something today? Anything at all? You FTP'd.
If you download
Anything.
FTP,
You FTP'd it. Now, how do you get to google.com? What's the URL? What do you type in? http://google.com. If HTTP is a protocol and FTP is a protocol, and if HTTP brings in the hypertext transport language, hypertext markup language, what do you think this guy brings in? Files. If you type in FTP://google.com, you will go to their FTP server, not their web server. Now, will it really happen today? No, not really. Why doesn't it happen today? When you went to that games.com and you went to download that latest game and you clicked on the link and said download it for free and it started downloading, how did you get it? You clicked the link and it brought it in, right? What happened behind the scenes? It went to you got a virus. It went to FTP://. It did it for you. You didn't know you did it, but you did it. That's what this does. So you've used lots of this stuff. This is all dead. This is mostly dead. Don't even know what this stuff is. So we live right here. So we just applied all that stuff we talked about on the other slide for people right here. Okay? Now, same concept. Oh crap, look at this. Okay? I'm not going to go over all this because we just kind of went over all of it. Look right here. Does this look familiar? Application, transport, internet, network access. Same thing we've been talking about, right? This is referred to as the TCP/IP protocol suite. This is the suite, if you will, hands wide open. This is the suite of protocols for TCP/IP. Now, the question was, what's the difference in the OSI model and the TCP/IP model? This is the TCP/IP model. How many layers do you see here? 4. 7. How many does this one have? 4. So they are different as far as the way they look. Now, hang on, we're going to take a break in a few minutes. So, what happens here? Protocol operation, sending a message, encapsulation happens. Now, what happens over here? We have Ethernet. What layer was Ethernet?
physical.
In the TCP/IP model, what layer was it? Layer 1, right? Okay. What happens after when it hits the wire? What does it have to do? How does it have to know for where it has to go? An address, right? It's got to know where it's going. What happens after that? What if it's a big packet? It breaks up into small pieces. It's called segmentation. That's TCP's job. What happens up here? It's just data coming in, right? Now, does this computer or this traffic know whether it's a picture? What if it's a picture? It might be a JPEG, right? That's different than HTTP. TCP would know that. Layer 5, layer 7, layer 6, that all happens in here, which we don't care about. Then there's the data, whatever happens. Now, this is going to talk about encapsulation and decapsulation. Let me give you a more brief description of encapsulation, decapsulation. Okay, very brief. Early on in this class, Grandma sent us a check, right? What was that check considered for us in general? That's the data, right? I mean, that's the data. What did she do with that check? She put it in an envelope, right? Okay. What else did she do to that envelope? Addressed it. Then what did she do? She sent it, right? What did that envelope really do? That envelope it held the data. It encapsulated the data. That's the word I'm looking for. Okay. What happened on the other side? So, goes through its system. It went through the mail system, right? What happened to that information? Was it necessary once it got to Grandma? No. Throw that away. What about the envelope the check came in? Do we need that?
Yes, it has an address.
Well, we don't need that. We just want the check, right? So we open up the envelope. We take out the data. What do we do with the envelope? 86 it. Now what do we have? The check, right? Did the check change? No. We encapsulated the check on one side, sent it across, and we reversed the process and decapsulated it on the other side. We put it in an envelope. We took it out of an envelope. I hate to tell y'all this, you'll be disappointed, but that's exactly how data networks work. They take that data that you're looking for, they encapsulate it, they send it, and they decapsulate it. Okay? Very simple. I know it's a lot of information, but it's not difficult information, right? I know it's boring. I get it. Okay? There are some organizations here, standard organizations, IEEE stuff. You don't have to remember this. Don't panic. This is a lot of crap to remember. But there are things that you will find common in our world. First off, you'll love this. All of these standards start with the same number, right? Same organization, 802. You want to take a guess on where that number came from? Remember, these are geeks that are putting this together, writing protocols all day, and they're bored. Big convention thing. No. That would be make too much sense. This actually came from the date. They had no idea what standard number to start with, so they started with the date of February 1980. It's that simple.
February of 1980.
Mm-hmm. 802, February of 1980. See, y'all thought this was all. You're going to be home. You're going to be talking to your family night at dinner going 802.11, 802.3. Yep. All right, what is this? So, we talk about Ethernet, right? What standard is Ethernet? 802.3. We've talked about wireless, right? 802.11. Have you talked about any of those other protocols in your lifetime? No. So guess how many we have to remember? Two. 802.3, 802.11. Now, just out of curiosity, have any of you ever gone to Fry's or Best Buy and bought a wireless access point? And you looked at this shelf and you saw all these choices. What choices did you have to make? Not manufacturer, but what choices did you have to make? Between what? Okay, but with the bandwidths, right? Did you want 802.11b? Did you want A? Did you want G? Did you want N? Good Lord, AC now? Oh, it's crazy. So, if I were to tell you that we were going to do 802.11b, what would that tell you? You don't pop me just rhetorically. That would tell you the bandwidth of that technology. The B is that version of, and when we get to the wireless, I'll go in way in depth about this. That's 11 megabit throughput. Okay? If I told you that we wanted 802.11a, that would tell you a bandwidth, 54 megabits throughput. Then you have to ask yourself, why would I buy an 11 megabit when I could have 54? There are differences in the technology. You'll cover all that. But did you buy a B or an A access point recently? What did you buy? Anybody remember what letter they bought?
N.
N? Did you know what you were buying?
Yeah.
What were you buying?
I was buying the bandwidth was the one that had the longest acceptance.
The one that had the biggest number on it, right? Why didn't you buy a G? Did you see G?
It was included.
It's included. Ooh, that's weird. G is compatible with A and B. N is a grouping of them. And AC is even more complex. Now, that is very generic. I'm not going to entertain and try to insult you to think that it's that simple. But there are reasons why you bought the letters you bought. And they're just a progression over time. And I'm not going to bore you with that right now. We will go over that in detail later, when I get to stand on my soapbox and share with you just how much I love wireless, which I know you remember how much I love wireless from the other day. Now, what is this cable? Ethernet. Ethernet, okay. What do we know about this? It's Cat5. What's Cat5 mean? What's Category 5 cabling? What does that, not specifically, but what does it mean? It's bandwidth. This is Category 5 cabling. What does the E mean? It's enhanced. Ooh, that's tough. Cat5e. So, Cat3, back in the day, that was rated for 10 megabit. Then you had Cat4, which was kind of a quick offshoot to plenum rated stuff, which means you could run it through air conditioning vents. Then we had Cat5. Cat5 was rated for 100 megabit throughput on your wire over here. Now, has anybody ever paid attention to what their bandwidth was when they plugged their laptop in at home or whatever? Anybody paid attention to that? What's the next jump from 100 megabit? No, not yet. Hang on to that thought. What's the next jump? 1,000, right? Gigabit, right? We like gigabit. Okay. What bandwidth was Cat5 rated at? 100. Can it do gigabit? Not very well, unless you buy the enhanced version, Cat5e. So, going on down the path there, gigabit became more popular, so we end up with Cat6. So this guy is barely rated for gigabit. Cat6 was designed for it. Now, there are explanations on what these cable types are, and we will get into those later, the differences in them, so you'll understand them. But that's what the Cat5e is for. So, and anytime you see a wired connection like that, it's Ethernet. Now, reference models. Okay, let's just stop for a second. Humor me as I go back. Okay, not there, not there, not there. What does that say? Protocol suites, right? Okay, what did the other one say? Not that one. What does that one say? Reference model. What's the operative words here? Reference models, I'm sorry, and protocol suites. Okay? So, this is a generic way to do this. If I said that this is a dog, and there are many dogs like this dog, what would you think that would be? A reference model or a protocol suite? Reference model, referencing what? Dogs, right? Okay, what if I were to say this dog has short legs, thin hair, red, flappy ears, long tail, and is a dachshund? What am I specifically calling out? It is synonymously protocol suite. Am I talking about all dogs or that one specific type of dog? Specific type. Now, what do you think a reference model does compared to a protocol suite? Think big. What did we talk about when we talked about protocol suites? One protocol in particular. TCP/IP, right? That model we looked at had how many layers?
4.
And it was specific to what? IP. Now, let's look at a reference model. Ooh. The OSI model has how many layers? 7. Man. What about the TCP/IP model over here, the reference model? 4. This was specific to what protocol?
TCP/IP.
Would you be shocked if I told you there is a AppleTalk model?
No.
What is AppleTalk? It's a protocol. It's a protocol. What about IPX? That's a Novell dead technology. It had its own model, right? Okay, but all of those models, no matter what they look like, would have conformed to a reference model. These protocol suites, this reference model. Now, this is where we live. What's up?
That's how it's broke down.
This is how they compare. So be very careful how you answer questions on this. So in the TCP/IP reference model, right, or protocol suite, the application layer is synonymous with the application presentation session, which would be layers 1, 2, 3, 4, 5, 6, and 7 are all here. So in the transport layer lines up, the network layer just gets renamed, and the network access layer are the bottom 2 layers. Now, why is this important? This is important because they're going to ask you stupid questions like the transport layer on TCP/IP model is the same layer in the OSI model as what? Transport layer. Then they're going to throw one at you. The internet layer is the same equivalent layer as what? But you're going to be looking for internet, right? No. Good answer. Now, this exists for TCP/IP. I get it. I mean, it does. This is where we're going to live. Have you heard me refer to a layer 3 device? Where do you think layer 3 devices live? Network layer. You've heard me refer to layer 2 devices. Where do you think layer 2 devices live?
Data link.
Data link layer. Now, this is a toughie. Where do you think this Ethernet cable lives?
Transportation.
Physical. You can touch it, right? That's the only thing you can touch. We are going to live right here. Now, I'll give you a little hint as we go through this. We as network people care about the physical layer, right? We need Ethernet cables, internet cables. I'm sorry, I misspoke. Internet cables. We need those, and we need to keep our cable guys employed, right? They have kids, and they have families, and they have mortgages, and they like to enjoy life. We like them. Okay? Data link layer. We haven't talked about that, but we will. The network layer. Now, just recall for a second. Bear with me here. It's only our second lecture, so bear with me. Where do we live as network people? We're lazy, right? We're lazy. I get it. Where do we live in the network? Right here, right? Do you remember what these are? Router. Do we know what routers are? A little bit? Not really? Okay. What layer do they live at? They live in network 3. So where do you think we live? Layer 3. We like layer 3. What's at layer 3? IP. We love IP. We love that stuff, right? Transport layer. We like transport layer. We like applications, don't we? I like Mobile Strike. I'm kind of addicted to that. It's because of that stupid Super Bowl commercial. I haven't missed a day since. We like applications. We don't care about presentation and session. Now, you're thinking, oh crap, how am I going to remember this stuff? First off, you don't have to worry about 5 and 6. We don't care about those 2. So that narrowed you down, didn't it? They got you at 5. Okay, of the 5 layers, what do you think the application layer is for? Applications, right? That's easy. What do you think the physical layer is for?
Media.
Wiring. Media. There you go. Medium. So that just leaves 3 layers we like. We love the network layer because, well, that's where our routers live. That really just leaves you 2 layers to think about. This isn't all that complicated. There's 7 of them. We don't care about these 2. Top and bottom are pretty freaking easy, if you ask me. Where does the word processor live? That's tough, isn't it? Okay. And when I get to the significance of this, you'll love that layer 2, as much as I do. Just kidding. Maybe not. Okay, so here's how it breaks down. Layer 1, physical, so bottom to top. Physical, data link, network, transport, session, presentation, application. So pop quiz, which 2 do we not care about? 5 and 6, session and presentation. We will talk about them, but we don't care about them. Okay, and I'll explain why we don't care about them. TCP/IP model, same thing. We talked about all this. We have been through all of this several occasions. This is a slide that if you were to print anything in this class, you should print this slide or have this drawn somewhere. Kind of keep it in the back of your mind. Only for this semester. You won't see this a lot going forward. Just for this test. So that's a little tip for you. We live here. We live right here, mainly. We will spend most of our time right there.